Why does magnetic permeability matter for Faraday's law? Imagine you are trying to turn on a light by moving a magnet near a coil of wire. The strength of the light depends on how much magnetic flux is created. But what controls that flux? It all comes down to magnetic permeability. Magnetic permeability measures how easily a material can support the formation of a magnetic field inside itself. Think of it as how well a material can conduct magnetic lines of force. When you have a magnetic field applied, materials with high permeability concentrate magnetic flux lines more effectively. This means they can produce a stronger magnetic flux for the same magnetic field strength. Now, Faraday's law states that the voltage or electromotive force induced in a coil depends on how quickly the magnetic flux through it changes. The faster the flux changes, the higher the induced voltage. But here's the key. The magnetic flux itself depends on the magnetic permeability of the material inside or around the coil. In simple terms, the magnetic flux density, which is how dense the magnetic field lines are, is equal to the magnetic permeability times the magnetic field intensity. In free space, this permeability is a constant called the permeability of free space. But in materials like iron or other ferromagnetic substances, the permeability can be much higher. This means these materials can support a much stronger magnetic flux for the same magnetic field strength. When a magnetic core with high permeability is used inside a coil, it increases the magnetic flux for a given magnetic field. This makes the flux change more significantly when the magnetic field varies. As a result, the induced electromotive force becomes larger, which is very useful in transformers, electric motors, and inductors. These devices relying on magnetic cores with high permeability to maximize the flux linkage and improve efficiency. On the other hand, if you use a material with low permeability, like air or plastic, the magnetic flux will be weaker. This results in less induced voltage when the magnetic field changes. So, the choice of material directly impacts how much voltage can be generated in a coil when the magnetic field varies. In summary, magnetic permeability is important for Faraday's law because it controls how much magnetic flux is produced for a given magnetic field. The more flux you have, the greater the change when the magnetic field varies, and the larger the induced voltage. This is why high permeability materials are essential in many electrical engineering applications. They help us create stronger magnetic fields, induce higher voltages, and make devices work more efficiently.